This conference will now be recorded.
Okay, so as we discussed about the basics of machine learning with Python and why machine learning is necessary, why Python is necessary, and all the other prerequisites, like all the other introductory things, like what is basically machine learning. A lot of examples that today's weather applications, today's like for weather forecasting, Netflix, YouTube, Spotify, like all the things that you are using, everything that you are using, even if you are using like you are using some other aeroplane for booking aeroplane tickets, for booking railway tickets, or the Amazon, Flipkart, everything you see in the modern world is completely based on in these things. Like if from Amazon, if you are ordering a mobile phone, then after that it will show you the tempered glass, the back cover of that particular mobile phone. The algorithm is designed in such a way that whenever you are buying something from the Amazon or from the Flipkart or from any other e-commerce service, they will assume, the algorithm will assume that yeah, you may need this one. Why? Because from the previous data, from the statistics, this is why the statistics is so much important. So suppose in 1999, from 1999, the evolution of the e-commerce side, the online e-commerce, this was like minimum, very minimum. And when with time it has grown this much amount of thing, like in 2022. There are so many data in these years, in these almost 23 years, or even before 1999, or before something from wherever it has started. All these things as like they have collected the all the data of their users, all the data from their users. They are collecting data from your entire mobile phone. You have to grant some access, you have to grant like your location access, that where you are. If you are in a beach, if you are in a beach, it will offer you something like your some beach clothings and some other things as well. So if you are supposing in a beach, so it will offer you some some other things that are necessary in beach. So if you are in mountain, it will offer you some other mountain stuff, some tracking suits and some other things. It will automatically track your location. It will get your location, and then it will show you the appropriate thing that yeah, you may need this one. It will like collect your information, that whether you are using your mobile phone for how much amount of time, whether you are searching for these products or not. And whenever you are searching for site, like say you are searching for a specific thing, over LCD television, you are searching for a LCD television for 5 to 10 times a day, 5 to 10 times a day. So automatically the data is being collected and data is being stored in the server. And in the server, it will analyze the data, that from the same IP address, from this particular same IP address, someone is searching for this television, suppose of MI television, this amount of time, 5 times or 10 times a day, for very frequently, like for 3 to 5 days. He is again and again searching for this product only. So then the algorithm will automatically think that okay, and the algorithm, obviously how the algorithm will think, that this is programmed in such a way that the statistics, that the old data has shown that if a person is searching this things this much amount of time, then probably he is gonna buy that good. So then the algorithm will automatically think okay, then it may be like of his or her interest. So then it will suggest him more in your Facebook profile. Whenever you are searching in your Facebook profile, it will show you this suggestion, it will show you this particular good. Whenever you are scrolling in your Instagram reel, whenever like you are doing something in your Instagram reel, it will show the suggestion of this good. If you are searching for a mobile phone, it will show all the suggestions for related to mobile phone. If you are searching for clothings, it will show all the suggestions for this clothing. So all the applications are interconnected and they are selling data, they are doing data mining. This term is very important, they are doing data mining. So data mining is what mine means, whenever you are extracting something from the mine, and data is being mined here. So data mining means just like this, that they are collecting your data, they are analyzing the data, and then they are like then they are plotting some graphs, then they are visualizing the data, and then they are predicting something, then they are doing something. Image recognition has also been like the machine is trained in such a way that it is fed with a lot of data that yeah, the suppose human face will look something like this. This may be oval, this may be round, of different persons, of like 1 crore or 2 crore, 5 crore, 10 crore persons, or male female of different types, with like some other problems also, all types of things, like there will be eyebrows, there will be eyes, and there will be a little nose, there will be a mouth, and obviously some hair. So if these things are there, so this may be a human face, but it will detect also ki whether it is a drawing or not. It will also be able to like separate this one kid, yeah, this is not a actual human, this is a drawing. So all these things can be done. Or suppose a person who is not having one eye, so she is also a human. Suppose he has some difficulties, or on in his face or in her face, somewhere something is there, so yeah, they are also humans. So the machine has been trained for them as well. So all these things has been fed to the machine a long ago. The data were like the data was collected, and then the algorithm was analyzing the data, then the machine learning model was analyzing the data, and then after like analyzing a huge amount of data, now the model is able to predict something, give some insights, or give some conclusions. And this is our lab. This is the reason we image recognition, not only about face recognition, about image recognition. This is a car, this is a like this is a laptop, this is a mobile, this is something, everything. Speech recognition also, a number of times, like our own speech, the model has been trained, image filtering, all these things, this everything was discussed. And these things are very basic thing. That's why I again discussed this once, because you should know the basic concepts behind machine learning, the thinking, how you should think, how you should like act, and what is exactly machine learning. Algorithms you will definitely be learning even after this course, even after everything. Once you have the interest, after that you will automatically be learning these things, you will automatically search, you will automatically learn, you will go for stuffs like that. But building interest is the main point. That's why I'm discussing again and again these things. Like that Instagram, whenever you are scrolling your Instagram actually like takes the data that how much time you spend on each and every post, how much second or how much millisecond. It calculates the amount of data whenever you are scrolling in Instagram, and after that maybe you are some reels you are watching it again and again, then it will show based reels or pictures or photos or everything based on that thing, that you how much time you are like spending on one single application. So this, even this much amount of data is being collected. They are storing the data like you are clicking on notifications or not. So all these things are from machine learning like model predictions and all these things. So yeah, this is why machine learning is like playing a great role in today's era. Without machine learning there is actually nothing. So now the next point is the difference between AI, ML, and DL. This has already been discussed. I will not discuss this one again. You know that AI is the main like this is the main thing, and under this artificial intelligence, machine learning is a subset, and under this machine learning, deep learning is another subset. So the contents like Python was discussed, some libraries, this all these libraries are discussed in a really great way. I have tried to show you as much example as possible to clarify with you. Then about supervised and supervised reinforcements and some projects. So Python libraries, basics and libraries, all these things were discussed in the last class. So now the type of machine learning, this is our new topic, and this is very important topic. Machine learning is basically of three types: supervised, unsupervised, and reinforcement. So supervised means whenever someone is supervising over something. Like whenever in Bengal, in West Bengal, there is a like concept in West Bengal or in UP as well, and also I have seen this in West Bengal, UP, and also in Assam also. Yeah, so some concepts are there while they are training, or they are like calling the teacher or calling the head as supervisor. Also there are in several things, but I was working here, and there everyone, like the teachers were calling their supervisors, their like their training, their instructors, this kind of terms. Yeah, and also in the corporate world, they don't call trainer, or they don't call like they just call with their name. Just, if I am Pradipto, you can call me only Pradipto, if in the corporate world. So trainers, supervisors, all these things are generally denotes the same thing. Supervised means whenever someone is like giving you a training, or someone is telling you about something, that you have to do this is this, and that is that, like how you have learned all the how you have learned all the writing, all the letters, all the digits and everything. This is called supervised learning. So your father or your mother has told you that like this one, this is called one, this is called two, in this way. This is called one, this is called two. Your father or mom has told you that this is this, this is that. So in this way you have learned to write, you have learned to draw everything. And what is unsupervised learning? Unsupervised learning is just basically when you are learning on your own, or and not, you are not actually learning, you are just like you are able to separate things. Like there are you are standing in front of a zoo, and you are able to see there are many animals. You are standing here in front of a zoo, and you are able to see there are many animals. So someone is maybe the structure of a element is like this. So yeah, I'm not able to draw it properly, but I was trying to draw an elephant. But okay, this is not an elephant, but okay, you may consider this as element. So this is very fat and like a great figure. And some other there is another like this one. So this is a giraffe, but this is not looking like a giraffe, this is rather looking like a dinosaur. Okay, so pardon my drawing, but yeah. So you are able to see the difference between elephant, you will see the difference the elephant and giraffe and tiger and all the other animals. So you are able to like differentiate between all these things. Yeah, this is something else and this is something else. So whenever you are doing something like that, and whenever you are again and again you are learning something from okay, so this, whenever you will see another animal maybe of different color, you will be able to recognize, yeah, this is of this particular class, like this is of this particular this animal or this thing is similar to that one. Or whenever you will be seeing something like a very small giraffe, not a big giraffe, then also you will be able to understand, okay, this is a small, this is like this is a subset, or this belongs to this set. So when you are learning like this, when you are learning like this only, then you will be able to like differentiate between all these things, that this, what is that. So yeah, I will be discussing about supervised algorithm, unsupervised and reinforcement in details. But you need to remember about some points, like there are some classification algorithm, there are some regression algorithm in supervised, there are dimensionality reduction and clustering in unsupervised, and reinforcement learning, this is basically for robotics. Like the evolution of Boston robotics, you may search this in your YouTube, and you can see a video, the evolution of Boston robotics or something like that. There is a robot and he is able to like do everything like a human being can do with it. Like in reinforcement learning, it actually like it learns from the environment, and it sees everything, and then it thinks by itself. So this is for the actual game development and real-time decisions. All these things are under reinforcement. This is actually discussing about everything in reinforcement. It is out of our scope, but the main thing that we will be discussing, and that most of the like applications and most of things are being developed with the help of supervised learning algorithm. So we will be discussing the supervised learning algorithm in detail. So these things are there. And now about supervised learning. So what is supervised learning? Um, if I have to tell you about supervised learning, you can see there are some labeled data. Labeled data means there are all the data are there, like this is a square, this is hexagon, this is triangle, everything. The labels are this is the labels. This hexagon, square, triangle, everything is given. All the labels are given, all the labeled data are given, and this is being provided to the model. There is some coding part, there are some other part, and with the help of some specific CSV files, some image files, and some with the help of something, you are providing the images, you are providing the labels to the machine, and you are writing some code, and you are providing everything to the machine. Okay, so now what the machine will do, the machine will like remember all the informations about these labels, all these things. So after that, when the model is trained properly, when you will provide this to the machine that please identify between this and this, so the machine will automatically be able to segregate or to differentiate between these two. And not only it will differentiate between these two, it will like give levels. This is a square and this is a triangle. So this is the basic concept behind supervised learning. Okay, so we can also classify dogs and cats with the help of this. If we are providing if we are providing images of dogs, if we are providing images of cat, so whatever we are providing, if there are labels, then it will be able to differentiate between all these things. Again, like supervised learning, when labels are obviously there, and also what we do, the aim of supervised learning is to like find a mapping function to map the input variable x with the output variable y. And what is the input variable? Like this one, y equals to fx. So the main goal is to find some output variable, that is y, that yeah, output is this with respect to the input variable x. So the for this one, when only the square is being given to the model, this is the model, it will predict something. And the goal is to predict something, like if I am providing the square here, so if I'm providing the square here, so we have to find some function that will give us the output. Yeah, this is a square. So this is our aim. So this actually, so if I have to tell you in actual real terms, so supervised learning is like a process of providing input data as well as the like correct output data, that and this is labels, the correct output data, and to the machine learning model, and then it will find a mapping function that will map the input variable with output variable. So where we use supervised learning, we use supervised learning in image classification, fraud detection, spam filtering, and also like risk assessment in banking and in all the fields. So this is all about supervised learning. So now if I have to discuss about some steps in supervised learning, so what it will do, the first step will be wait. Okay, so the first step will be to to determine the proper data set. then it will collect all the informations from the training or all the labels from the data set and from the label. Then it will split the data set into two part, the training part and testing part. It will automatically, this is the entire data, it will automatically split the data in some part. Like in some part, the way it wants. So this is not a proper like this is not a proper line for dividing, because you may see here are only hexagon and squares but no triangles are there. So the training data and testing data cannot be differentiated in this way. It should be differentiated in such a way that while training all type of data will be there, and also while testing all type of data will be there. So this is not a proper line. So what else we can do, that training and testing data should be divided in such a way that all the fields will be there. So how we can do that? So we have to like that is the aim. We have to find some function the way we want. So how can we do that? We can like there can be something like this. No, this is also yeah, this is possible. The something like this. This is possible, the something like this. Suppose this part is training or this part is training and some other part is testing. For training you have to use, for testing you have to use of 100%. Hello, am I audible?
Yes,
Yes, sir.
sir. But
Okay,
your voice is breaking.
actually I lost, suddenly I lost my internet connection. I lost the, so now am I audible properly?
Yes.
Yes, sir.
Okay, just give me a minute. Let me fix my Wi-Fi once. Just give me 1 minute. Okay, so this is about like my favorite percentage is 75% training and for and 25% is for testing. Also, I divide like 70% training and 30%. Sometimes it depends on the choice, and sometimes 80% training, 20% testing. So this is about like for me like based on the input features and output, like what I have to do, I decide this. So then I execute, then what happens, then I execute the algorithm on the particular training data set. on only the training data set, the 75% training data set, I execute the algorithm. Not only I, all the machine learning, they are executing the algorithm on the training data set. Sometimes like we need some validation sets as well. What are validation sets? These are for like validating our answers, that yeah, the machine is predicting right. So, and that is also a subset of this this is suppose the entire training data set is a set, and the one subset of the training data set is our validation data set. So in the validation data set, like the name suggests, what is validation? The validation is for like validating our answer, that yeah, the machine is predicting right. And then after everything, like all the training and validation has been done, then it is the part for testing our data. So what we do while testing our data, so we will basically evaluate the accuracy. So how we can evaluate the accuracy, how we can calculate the accuracy, everything will be discussed, no worries about that. So this is the basic theory, that how we can like divide the data set, what we can do. So one more thing I want to discuss, this is about like how, differentiating your data set and like breaking your data set. So another point is, you may see that one point is this is one point and one point, and this is another point. There are two type of supervised machine learning. So there are two algorithms, are basically there are two algorithms. Okay, let me write it in a good way. This is okay, I'm marking this as 1 and this as 2. So there are two types of machine learning algorithms. One is regression algorithm, another is classification algorithm. Supervised is the name, or like in supervised algorithm there are also some subparts. So what we do here, there are some like examples: population growth prediction, estimating life, and there are some like many examples also, not only this. But what we do, so regression algorithms, what are regression algorithms? Regression algorithms are used if there is a relationship between input variable and output variable. If only there is a proper relationship between the input variable and the output variable. So when there is a proper relationship between this x and this y, so we have to find something. Sometimes it may be c, and what each of the cases, these are proper with the slope, the slope. Okay, my voice is breaking, but I'm using my Wi-Fi. Am I audible now?
Yes, sir.
And now the voice is breaking, or it is now properly audible?
Now, sir, it's popular.
Okay, okay, thank you. I don't know why is this happening, but I just checked my internet connection, the speed. It's like 20 Mbps, so I don't know. Okay, no problem. So let me discuss something. I was discussing about the regression algorithm. So regression algorithms are used if there is a proper relationship between the input variable and the output variable. And it is used for prediction of like continuous variables such as weather forecasting that I was discussing. While weather forecasting, market trends, and some other like all these things, these are the part of regression algorithm. There are some like also this regression algorithm can be divided into some other algorithms like linear regression, regression tree, non-linear regression, Bayesian linear regression, polynomial regression. There are several things in regression, and this regression will also be discussed in a huge portion. And also there is something like classification algorithm. So classification algorithm are used when the output variables, like when the output variables are categoricals. Over the categorical variable means like there is also yes or no type questions. There is this a like is this a apple or not? Like is this a circle or not? The answer is yes. The answer is yes. Is this a square or not? The answer is yes. Is this a triangle or not? The answer is no. Is this a hexagon or not? The answer is no. Is this a triangle? So this kind of things, like all these things, like is this a spam or not? The spam or not, like yes, no. Is this a male or female? Is the answer of this question is true or false? So this kind of things, when like these are only one word thing or one type of thing, so like if else things, then we use classification algorithm. So you can see identity fraud detection. So is this a fraud identity or not? The answer may be yes. Image classification, again image classification. So is this a dog or not? Is this a cat or not? Is this a human or not? All these kind of questions. Is this a male or female? Is it a car? Like this kind of things, customer retention. So there are several, whether this person is having, whether this person is having any cardiovascular disease or not, whether this person is having some like brain disease or not. I hope you are getting like this kind of questions. Whenever you will have some categorical questions, which means there are only two classes, yes, no, like male, female, true, false, COVID positive, COVID negative, normal, either COVID positive, either normal, cardiovascular disease with or without cardiovascular disease. So this kind of thing, spam filtering, all these things. So there are also several type of classification algorithms like random forest algorithm, decision trees, logistic regression, and support vector machines. There are we will obviously we will discuss all the these algorithms, and also all these algorithms. We will discuss all the algorithms in details as well. So this is about the supervised learning, and we discussed about supervised learning in as much as we can in the basic level. Also, we will go to the pro level as well, where we will be really coding this kind of problems from scratch. I will be showing just like the yesterday, not the day before yesterday. I showed you, I presented you all type of coding from scratch, and I will write code from the scratch for you all guys, and I will show the code also. So now you may ask the advantages of supervised learning. What are the advantages of supervised learning? So like also in our case, whenever we are learning or whenever we are taking trainings from a supervisor or from a trainer or from a teacher, the model will also be able to predict the output or predict something on the basis of its experience, its prior experience. we can have like an exact idea about the classes and objects, and also like all this kind of problems. You know how much important this is. Is this identity a fraud or not? Is this a male or female? Is the person is wearing a mask or not? So all these kind of things, this can be done using like classification. And when we have to like map a function, when there is an exact relationship between x and y, suppose in this kind of relationship, or like sigmoid relationship. So whatever the graph is, but this kind of things are called like there is a relationship between these two things. So these things are like all about supervised learning. This is, I think, this is enough for you all guys. And now I will go for this. This is about supervised learning. I have written something like supervised learning is a type of machine learning in which machines are trained using well labeled training data. So you can read this slide, and you can like whatever I discussed, everything is clearly written here. So take a minute or two and read this slide once. Okay, so now we will discuss about unsupervised learning. So what is unsupervised learning? You can see in this image. So there are no labels. The first point and the most important point is there are no labels. No labels means you will not tell the model that this is a cat. You will not tell the model this is a fish. You will not tell the model these are birds. You will not tell the model that this is a dog and these are dogs. This is another cat. This is another cat. This is another bird. You will not tell the model anything. You will just literally, you will not tell the model anything, and you will just provide all the input data. You will provide all the input data to your model. You will provide everything to this model, just literally everything to your model. You will write your code in this way that you will provide all your input to your model, and the model itself will differentiate based on their behaviors, based on their characteristics, based on their like properties, that the designs. It will classify. There are several things that needs a proper discussion, but the model will differentiate between all these things. Like the model itself will differentiate. Yeah, so all these things are birds. These are, so no, not only birds. It will not be able to understand this is we human, we know that these all are birds, but the model will understand that okay, so all these things are of some type. These are of same type. These are same type. So all these things are of same type. This model will identify these all these things are of same type. This model will identify that these are of same type. So like, yeah, there may be a little bit error while dog and cat, proper identification between dog and cat, it will not be able to. But the facial recognition, like the facial who has this kind of face, and who are like only this kind of faces, these are like either dogs or cats or this kind of things, who are having this kind of wings, this kind of thing. There all the birds are different. All the these are birds, these are animals, proper animals, and these are fish. So the model will be able to differentiate between all these things. So what we do in like unsupervised learning, there are many classes and we don't provide any labeled data, and the machine will find out the hidden patterns from the given data. given data set. All the patterns, it will automatically find out all the hidden pattern from your given or your input data set, from your input data set. And and then it will automatically differentiate between them. So unsupervised learning, as the name suggests, guys, I don't know why today my internet connection is really, it's not letting me take the class properly. So the model itself will identify and itself will differentiate between all the terms, that yeah, this is a dog, this is all these things. So what happens in unsupervised learning? Unsupervised learning, as the name suggests, this in this type of algorithm, that model will find itself the hidden patterns from the training data. So it can be compared to machine learning, like wait so it can be like all these of things, all the hidden data, those are like in human being, we how we think, how we differentiate, it works in the same type. So there is a very popular code that unsupervised learning, like this kind of code, unsupervised learning is a type of machine learning where the model learns by itself, and it is the best machine learning without any supervision. It learns, it is like everything is done from the scratch, and it is the only machine learning, the proper machine learning. There are so many rumors, so many things. So these are cannot directly applied to a regression or classification problem, because there are no labels. So we have to give some input, but we will definitely give some input, all this data, but there will be no labels. So this is a little bit hard for the model, but to find the underlying, like for the finding the best structure and all the features, it will extract all the features, and then it will represent this, and then it will differentiate between them. So these things are like done. So if I have to tell about like also like for like example, there are so many example like this one also, and also for also we will discuss about examples, but let me discuss about the this part about dimension clustering and association. Dimension reduction is basically, and also there is something like association. So what is clustering? Clustering, as the name suggests, it is a method of like or making clusters. Clusters means some groups where there will be some items of same type. Cluster means some group. So and into that clusters, that objects are like objects with so much similarities will be in that group. Like this was a cluster, like this was a cluster, this was one cluster, this was another cluster, this was another cluster. So objects with same similarities will be in the same cluster. And association is also like association was I was discussing about association, that whenever you buy something from your Amazon or from your Flipkart or from any e-commerce site, so it will automatically like find the relationship between some variables, automatically find the relationship. Like when you are buying a mobile phone, it will automatically suggest you, it's like you are most likely to buy the tempered glass or the back cover of that mobile phone. If you are buying a laptop, then you are most likely also that you will buy some external keyboard or external mouse or something else. If you are like if you're like some if you're like some, if you are if liking or if you are buying some jeans, then definitely you may search or you may buy some attractive shirts as well. So it will automatically determines the set of items that occurs together in the data set. The data set is given in such a way that there are some set there are some there are some items in the set where there is a mobile phone, the tempered glass, the earphones, and this all there are so many things, the mobile accessories, all the mobile and mobile accessories are there in the set. In this set all the mobile and mobile accessories, everything is there in this set. And also there are so many this kind of sets. So in the food also, if you are liking, if you are buying some custard, if you will definitely buy some other food. So yeah, there are so many things. So it determines based on the set of items that occurs together or that we are together. And association is really very much effective in terms of business, in terms of predicting the like market analysis, market business analysis, as you can know. So in the Amazon and Flipkart, these things are growing so much. Amazon was the was the biggest company in the entire world, the richest like. Now Tesla is, but some time ago the Amazon was the best company and Amazon was the biggest company, the richest, like some billions. So only this without this unsupervised algorithms, it would not have been possible. So now the next point is that how many types of unsupervised learning algorithms are there? There are literally so many algorithms, like K-means clustering, KNN is K nearest neighbor. These two are very popular. And apart from that, there are also some other algorithms like a priori algorithm or independent like component analysis and all this kind of like this. And also neural networks are there in the unsupervised learning. Based on the neural networks, we can do something with artificial neural networks, that is a part of deep learning as well. Anomaly detection, there are several things. So what is the basic advantage of unsupervised learning? As you can know, that unsupervised learning is like more also it will help to execute some really complex tasks and really complex task as compared to supervised learning, because we don't have to provide any labels for the input data, right? So that's why it will like do all the complex stuff with very ease. And in the unsupervised learning, it's really very preferable in case of unlabeled data. So when we really don't have the labeled data, then how we can do that? Firstly, unsupervised learning will for a human or for a group of human or for many human, it is really near to impossible to like do or classify or to like make clusters of this much amount of things. So it is really impossible for everyone. So the machine, when the machine itself will classify all these things, and then the human may label all the data, all the things, that can be done. So these are for this like these are basically for everything about unsupervised learning. So now about enforcement learning. So what is reinforcement learning? You can see it is like a feedback based machine learning technique. And what is feedback based machine learning technique? That it will learn from the environment, or in the robotics, in the game playing, that it will identify itself that whether it is making errors or not. Suppose a computer is playing chess with a human, so it will learn from its mistakes. It will learn from the feedback that yeah, this is right, this is wrong, and it will increase its efficiency, its efforts with time, and obviously with some. So these things are like the reinforcement learning. For you can see the definition, and all the important thing about reinforcement learning is written here. You have to remember about this is really reinforcement learning are really very popular in game playing, like when where a robot is playing a game with a human, and in robotics. So where decision making is likely to be similar to the human. So there we have to use these things. So in reinforcement learning, the agent learns automatically. So using feedbacks without using any label data. So this is very better than supervised, and also it is better than unsupervised because it learns itself, and it automatically it will learn. So it will automatically search, it will automatically learn. And suppose in the unsupervised one, we are able to only cluster, we are able to only differentiate between these terms. But if there are some algorithm or reinforcement learning algorithm, so maybe we will be able to classify, and we will be able to write that these are birds, these are fish, these are cats, and this can also be done. So that's why reinforcement learning is very necessary. Okay, so this is about the basics of machine learning. Now we will just think about it and just take a minute or two to recap that whatever is discussed till now. So now we will learn some more theories that what is batch and what is online learning. Batch learning and online learning. These are some terms, very popular terms in machine learning. Yeah, actually in the actual implementation in the real life examples, you will be needing these terms. So whenever you will hear some terms, definitely these theories are little bit boring. These theories are not so interesting as practical. But when you will be actually coding, and then suppose your friend or your senior is telling, okay, increase the batch value or increase the stochastic gradient value, or the online learning, please change these values. So at that point, if you are not able to understand that what he or she is trying to say, that is your drawback. So that's why you have to understand all the theories as well. So now about batch and online learning, you can clear everything is written in this slide. That's why I have uh, I have built this slides for you all. So what is batch and what is batch learning? This batch learning represents, you can see, that represents the training of machine learning model in a batch manner. In a batch, there are some uh, whenever we go for a reception party or some marriage party or some any other occasions, so there are some batch. This is first batch, this is second batch. Whenever we go in a college, so there is a batch. This is first batch, this is our second batch, this is batch A, this is batch B. So whenever we divide some peoples into some batch A and batch B. So in this type of problems, these things are batch learning, and the data gets accumulated over a period of time. The model then get trained with that particular accumulated data from time to time in a batch manner. Like you are dividing the entire data set into some parts, and then you are training the model over and over among these parts, and then you are training the data in the batch manner. So these things are like for batch learning basics. And about online learning, in online learning, it is like great for machine learning systems. Why? Because that receive data as a continuous flow, like stock prices online. In the stock prices, this is basically for online learning, because stock prices are continuously increasing, and continuously the values are being changed. So that's why the values are changing. Okay, so please look at this slide, and then I will be discussing the next points. Okay, so now the next thing is about instance-based and model-based machine learning. So you can see the images here, about instance-based machine learning and model-based machine learning. Machine learning are classified into several fields. You can classify machine learning algorithms. You can differentiate in between machine learning algorithms in terms of different things. In terms of, there are many different things to classify and to differentiate between all the terms. All right. So about instance based and about model based learning, what are they? So when the instance-based learning is basically the case when the learning, like when the entire data set, you can see here, when the entire data set is used as the model, when the entire data set is used as the model. So what does this mean? Whenever we are using the entire, suppose you are downloading a data set from the Kaggle, and there are total this is the data set. I'm just drawing this data set. Always remember, it's not the case that always it will be a CSV file. It will not be the always case, because I will show you projects. I will show you, like I will show you a project in our project section, that where we will be like uploading images of 5 GB to 10 GB, 5 GB images. So if you are not able, like you no need to worry about it, because if you don't have that much amount of internet, then I will, like I will upload the file into my either Dropbox or into my Google Drive. I will prefer Dropbox, because Dropbox is like from there and the space is like yeah, in my Google Drive I'm running out of spaces, so I will upload the file into my Dropbox or into my Mega Drive, and then I will share the link with you. You can directly import with the help of this link. So this is about, like about instance based, that where we will be using this entire data set, the entire data set as the model, for the model. So in k-nearest and knn algorithm and some other algorithms also, the feature vectors, and the entire data set is being used by these kind of things. And what is model based learning? In model based learning, the algorithm use the training data to create a particular model. So it will, the algorithm itself will use the training data, and it will differentiate between data, and it will create some model that has some parameters, like these are some based on some parameters, and from that, like in support vector machine. So these algorithms will definitely be discussed in detail. The knn algorithm and the svm algorithm, this will be like clearly discussed. Okay, so the next thing is about model based and instance based. uh, like there is a lot about instance based and model based learning, but about like instance based learning is like, it is called sometime memory based also. Remember this term, this is also sometime called memory based learning. So what is memory based learning? So memory based learning, it is called because it is of like in this part of machine learning, in this part of in this type of machine learning algorithms, that they like instead of performing some explicit generations and explicit type of things, they compares the new problem instances with instances seen in the training. So they, what did I say? Instead of performing some expliting like operations, they compares the new problem instances with some other instances to that is seen in the training, which have been stored in the memory. So that's why it is also called memory based learning. And in case of model based learning, in case of model based learning, what happens? In case of model based learning, the machine learning are like parameterized. So that I was telling, that it was parameterized with a certain number of parameters that do not change as the size of the training data changes. So if you are like wait for 1 minute. So like if we are using a 5,000 images, 5,000 images, or suppose we are using 1,000 images somewhere. 5,000 is the training data, 1,000 is the testing data, and some other time we are using like 10,000 images. We are using 10,000 images, and we are using also some other amount of testing data. So even if the training data is like increased, training data has been increased, the size of the parameter and the number of parameters will not change as the size of the training data will change. So if you don't assume any distribution like normal distribution, there are several distribution things. So if you don't assume any distribution with a fixed number of parameters over your data, for example, like in knn algorithm, or in a especially I think it is a decision tree, or in a decision tree, or the random forest algorithms, or this kind of thing, where the number of parameters will grow, or the number of parameters will increase with the size of the training data, then you are not model based actually, because in the knn, the number of parameters will not increase. In the especially in the decision tree, the number of parameter will not increase, either yes or true, either this is a male or this is a female, the number of parameters will never increase. And also but in model based learning, the number of parameters will never ever increase. So this is the most important thing, that in model based learning, models are parameterized with certain number of parameters that do not change their size as the size of training data will increase. So if you don't assume any distribution, something like that, where there are fixed number of data, so if you are not able, then that is not like knn or the random forest algorithm. Those things are not for, those things are really not for like non-parametric, and then that the size will definitely increase. So you are not in a model based learning, right? So this is basically about model based and instance based learning. So now the next thing is overfitting, underfitting of data. and also appropriate fitting. So this thing I was discussing, so remember the example where I was discussing about squares, rectangles, squares, triangles, and circles, hexagons. There were, yeah, there were different things. So we will plot the variance, or we will plot the line in such a way that in the training field or in the testing field, all the data will almost be equal. So this is the example. This is an example of underfitting, because you may see here in this part, crosses are more and as compared to the circles. So the model will be trained with the crosses more and the circles, and the model will not be trained with circles. So this is the reason for like the model will not be a proper model. The next thing is about overfitting. Like that, if I am like if I am like all the things are like almost everything is here, almost everything is here, all the crosses are here, and all the crosses are under this line, everything is under this line. There is no this model is overfitting. Like this is 100% accurate. This is 100% accurate. All the crosses are here, and all the circles are here. So this model is 100% accurate. This model is able to differentiate between crosses and circles. What is this model is doing? This model is differentiating between crosses and circle. There are some number of crosses, and there are some number of circles. So this model is basically, the machine learning model is basically classifying or differentiating between crosses and circles. So in this model, all the crosses like are the model is able to differentiate all the single crosses. So this is overfitting. And always remember, this kind of thing are also not like this kind of things are not taken, and these are not accepted by official or by like higher authorities of machine learning. So if your model is giving 100% accuracy, or the accuracy is is written actually in terms of 1 or 0, from 0 to 1 there can be some point, like 0.5 means 50% accurate, 0.6 means 60% accurate, 0.7 means 70% accurate. So if your model is if your model is like this only, that all the crosses are the model is able to differentiate between all the crosses, and something like this, then this is the example of for overfitting. And if the model is able to predict this kind of thing, like yeah, there are 1 2 3 4 5 6 7, all the things, there are 7 crosses almost here, this, and there are 1 2 3 circles are here. So this model is underfitting. Like this is really very simple. So the appropriate proper fitting function will look like something this, where yeah, there may be 1 or 2 cross here, or yeah, there may be 1 or 2 circle here, but not, it will not be like that all the elements will be, some of the elements will be here, some of the elements will be here. At least for one element it is showing almost 100%, and for some other elements it is showing some difficulties, like the model is almost 98% accurate or 97% accurate, we can say. So this is this is a really great model for deploying, because if there is no error, in this model, there is no error. So if there is no error, then the scope is like minimum. The scope is really minimum there. If there is no scope to improve, then this model is really very bad model. This is, although it is giving 100% accurate, then must be in your data there is some error. So when I was learning, I had made this kind of errors a lot. So please avoid making this kind of errors, that don't like build a model something like this. Yeah, the validation accuracy can be 100%, but not the testing accuracy. Okay, so yeah, done. Now the next point is MNIST dataset in CSV. So I will give a general introduction about MNIST dataset. So what is MNIST dataset? MNIST dataset is for the dataset is there is a number of handwritten characters, handwritten digits, 0, 1, 2. All the zeros are of different types, 1 of different types, 2 of different types. So there are like many images in this file, in this MNIST dataset, and all these things are like handwritten. So we use this data set to feed the model, and we provide all the informations to the model, and after that the model will be able to like understand our handwriting. So if I am writing 1, so then it will be able to understand this is a 1. So if I'm writing 1 like this, it will be able to understand. If I'm writing 2 as this, it will be able to understand, yeah, this is 2. If I'm writing 3 as this, so we are training with this much amount of data so that the model is able to understand any kind of like it can predict anything. And MNIST dataset is really very popular. So this is a very large dataset, and basically we use TensorFlow and deep learning in the field. So now you know about MNIST dataset, so you can go online and you can search about MNIST dataset, and now you can download the MNIST dataset also, or you can simply import the TensorFlow in your Google Colab, and from there you can import the MNIST dataset from TensorFlow, import MNIST. So and then you can like start using the MNIST dataset. You can perform different operations in the MNIST dataset. Okay, so now the next point is about this is classification algorithms. So this classification algorithms will definitely that I discussed. Okay, so I have to remove this 2 and 3. So now the thing is the classification algorithms. So what are the classification algorithm and what happens in classification algorithm? As I discussed with you, that classification algorithm is a proper type of in this type of machine learning algorithm, either there is 1 or 0. So these things are for classification algorithm. So now from now onwards it will be discussed in detail, no worries about it. So this will discuss in the next class, because today we discussed a lot of theory. And now let me take the attendance first, and I will ask some questions to you also, so please don't leave the class now. I will first let me take the attendance. So I'm calling your names, Ankur Mandal.
Yes, sir. Present, sir.
Okay. Anurag Basu.
This conference will now be recorded.
So what I want, I want that this is like actually I showed you yesterday that how you can like number of rows, number of columns, how you can do that, and how you can also assign titles to it. How you can like this is the part of subplot. So how you can assign titles, how you can write some other things as well, everything you can do with the help of subplots. So I want 4 different types of subplots, 4 different types of subplots with title and with different colors. Please do that one and send it here. I will copy the code and I will execute it in this in my Google Colab. Moinak, do you wanna say anything? Okay, no problem. So basically, whatever I discussed, please think about it. That you have to like practice machine learning and all these things a lot.
This conference will now be recorded.
Guys, are you all trying or not? Okay, doing. Am I audible or not? Okay, doing. Okay. Okay, that's great. But please, uh, this shouldn't have take this much amount of time. And I don't know why all the people are leaving the meeting. Almost almost 90% people left the meeting just after the attendance. So I used to take the attendance in the last time, but I saw that you all are like someone is leaving. That's why I thought, okay, I will take the attendance sometime before. But anyone is done with the code or not? So okay, you're not able to do okay. So Yeah, no, actually, there is not the solution right now. But I thought you will be able to. But no problem, Aditya, no problem. So in the subplot part, what are these three things? The first one is number of rows, the second one is number of columns, and the third one is index. So we will design this one just like number of rows, number of columns. So please try it in your home. Otherwise, I will show you in the next class. Okay, this is your homework.
Okay.
Okay, thank you. Bye bye.
Bye bye, sir.